All right, let's talk about something that is probably lurking in your C# code right now. A massive performance trap. And the craziest part? It all boils down to two little words that look almost identical but behave in ways that are worlds apart. We're talking about IEnumerable versus IQueryable.
So picture this. You're writing a query, and you have to make a choice. Are you going to declare your variable as an IQueryable or an IEnumerable? They look pretty much the same, right? It's just one word. But I'm telling you, one of these is way faster than the other. Go on, take a guess. Which one do you think it is?
If you bet on IQueryable, you are absolutely right. But here's the real shocker. It's not that it's faster, it's how much faster. We are talking a 20 times performance boost, sometimes even more, all from changing that one single word. So, how on earth is that possible? Well, that's exactly the mystery we're going to unravel today. To really get a feel for this, theory just isn't gonna cut it. We need to see this thing in action. So let's walk through a real-world scenario and see just how bad things can get when you make the wrong choice. Okay, imagine you're dealing with a huge database table, 1 million log entries. Your job is to find a few very specific records by applying a couple of filters. First up, you try the IEnumerable approach. You define your query, and then you start chaining on your where clauses to filter it down. Seems totally logical, right? And this is the exact moment it all goes horribly wrong. Take a look at the SQL that actually gets sent to the database. It's just select everything from weblog. It completely ignored all our beautiful C# filters. It's basically asking the database for everything, all 1 million records, to be dragged across the network and dumped into your application's memory. And the result of that insanely inefficient query? A jaw-dropping 90 seconds. Just think about that for a second. That's 1.5 minutes where your application is just frozen. It's pulling down every single one of those million records, just so it can then start doing the filtering work that the database was built to do in the first place. Ouch! Now let's just make that one little word change. We're swapping in IQueryable. The C# code looks identical, but just look at the SQL it generates now. This is where the magic happens. It's not a dumb select star anymore. Entity Framework has translated all our C# filter conditions directly into a smart, optimized SQL query with a proper where clause. And the execution time for this intelligent query? 4 seconds. Just 4. We went from 90 seconds down to 4. That's, what, a performance improvement of over 2,000%? It's nuts. So the million-dollar question is, what is this magic? How does IQueryable do this?
To understand this wizardry, we have to start with the most basic concept. We have to know where the work is actually being done. Is it happening on your app server, or is it happening on the database server?
You know, here's a great analogy for this. Using IEnumerable for a database query is like walking into a library and yelling, "Give me every single book you have on history." The librarian just dumps a mountain of books on your desk, and now it's your job to find the one you want. That's client-side in-memory filtering. But IQueryable, that's like handing the librarian a very specific note. I need the book on the Napoleonic Wars published after 1850 by this author. The librarian does all the hard work and just brings you that one book. That's server-side execution. You let the expert, the database, do the heavy lift. But how does IQueryable know how to write that perfect little note for the librarian, right? How does it translate your C# code into SQL? This is where we get to the real secret, a super powerful concept called an expression tree. Now, don't let the name expression tree freak you out. It's a really simple idea at its core. Instead of compiling your C# code into instructions that run immediately, the compiler turns it into a data structure. Think of it like a blueprint or a recipe. This recipe describes the intent of your code, like, I want to filter by this, then take the top 10, in a language that something else, like a database provider, can actually read and understand. So this is how it all flows together. You write your LINQ query, the compiler sees you're using IQueryable, and builds that expression tree blueprint, instead of just running the code. Then, a provider, like Entity Framework, takes that blueprint, translates it into super efficient SQL, and only then is it sent over to the database to be executed. Your C# code literally becomes the database's where clause. Okay, so now we know the what and the how. Now let's get to the most important part. When do you actually use each one? Let's lay out some simple rules of thumb.
The rule is actually super simple. Use IQueryable anytime you are building up a query against an external data source, like a database. It lets you keep adding filters and conditions before anything actually happens. You use IEnumerable for data that is already sitting in your application's memory, like a simple list. In fact, the moment you call a method like .toList on your IQueryable, the query runs, the data gets pulled into memory, and you've effectively switched over to working with an IEnumerable.
And this brings us to a really critical piece of wisdom from developers who've been burned by this. Do not let IQueryable escape your data or repository layer. Why? Because its execution is deferred, it's delayed. If you pass an IQueryable around your application, some other developer, or hey, even you 6 months from now, could add another filter that's impossible to translate to SQL. And poof, the whole thing silently falls back to running in memory. And you've just created a performance nightmare without even knowing it. The best practice? Build the query, execute it by calling .toList, and then return a safe, predictable IEnumerable.
So there you have it. A single word that can be the difference between a 4-second query and a 90-second disaster. It really all just comes down to knowing your tools and, more importantly, understanding where your code is actually running. So that leaves me with one final question for you. Now that you know the difference, where might a 90-second mistake be hiding in your code?